the shape? In the diagram, what was the shape? It's a rectangle. It's a rectangular tank. It's a rectangular tank. Okay? So the formula for the volume of a rectangular tank is, let's see if they were listening a bit.
Over dt, right?
Hey! I know, I'm so bad at hiding.
Okay, what's the volume?
dv over dt.
Because that's the formula. How did they get the 6H? What? It's not the derivative. It's just the volume of a rectangular tank.
So why are you asking me?
I'm asking you, what's the volume of a rectangular tank? Anybody? Volume of a rectangular tank?
H times W times.
Length times width times height.
Correct. Length times width times height. And since the length is 3 and the width is 2, so that's why it's 6H. Okay?
Yep.
Okay, so if there are no more questions, that's it.
Good job.
Let's have the job.
The tank stands point down and has a height of 10 feet and a base radius of 5 feet. How fast is the water level rising when the water is 6 feet deep?
So we know that dv over dt is 950 cubes per minute. We know that the height is 6, and since we don't know dr over dt, we're going to write r in terms of h. So since r over h is equal to 5 over 10, r is equal to h over 2. And the equation for a cone is v equals 1/3 pi r squared h times h. So we substitute our values, then we find then we simplify, and v is equal to pi over 12 times h cubed. Then we differentiate here, and we find that dv over dt is pi over 4h squared times dh over dt. Then we substitute 9 and 6 that are given from the problem, and we find the final answer, which is 1/5 feet per minute.
Can you explain to them why there was a need for you to change the R to H?
Because usually when we find the derivative of this, we're going to find a dr over dt and a dh over dt. But since we only had dv over dt, and we were looking for dh over dt, and we had no dr over dt, we wrote r in terms of h.
Yes. Thank you.
Good job.
Good job.
What's the shape?
The police determine the distance between them is increasing by 20 miles per hour. And if the cop is moving at a rate of 60 miles per hour, what is the speed of the car? So we're given that dz over dt is 20 miles an hour, and the dy over dt is 60 miles an hour. So to find dx over dt, we have to use this equation: x squared plus y squared equals v squared.
Okay,
And then
stop, Kevin. Can you tell them first where's the police and where's the police and where's the guy?
Marcel's to the south of town.
I know, but tell us.
I think this would be the
car,
car and this is the truck.
the cruiser.
Yeah.
Okay.
Alright. So we have x is 0.6 and the y is 0.8. So we have 2x times dx over dt plus 2y over dy over dt and 2z times dz over dt, which you can pretty much take out all the 2's and you just get them out once. And once you get this equation, you plug in the x and the y's that was given. So you get 0.8 times dx over dt plus 0.6 times the negative 60, which you get from here, equals the square root of 0.8 squared plus 0.6 squared times 20. And then you just drop the 0.8 down. This turns into negative 36. And then this is going to turn into 1 times 20, which is 20. Then you add the 36 to each side, so you get 0.8 over dx over dt equals 56. Then you divide by 0.8, and you get the dx over dt is 70 miles per hour.
Okay. What's missing? The very last step. What's missing there?
What?
What's missing in the presentation? Remember what I said? What I wanted to be there in the presentation? What's the last one? What's the last part that I wanted to see?
Tie it up.
You have to answer the questions.
What question?
Okay, go back to the problem. If the cap is moving, at what is the speed of the car? So you have to write it in statement form. Write it in statement form. The markers are there, Kevin. Write it in statement form. Oh, you didn't do that, huh?
I don't think anybody did.
No, they did. The first group did it.
Oh, we did it.
You have to write it in statement form. Yeah. Just put the answer in statement form. Guys, you need to remember that. In the test. Hello. In the test. What test? We will have a test on related rates, right? Do we agree on that? We will have a test on related rates. Now, my test on related rates. I would look for that answer at the very end. Okay? Thank you. The speed of the car is 70 miles per hour. So, is he getting it?
Yes.
Yet, because that's more than the speed limit. Okay. Next one.
An airplane is flying on a flight path that will take it directly over radar's back station, as shown in the figure. If S is decreasing,
Slow down.
I'm sorry. If S is decreasing at a rate of 400 miles per hour, when S is 10 miles, what is the speed of the plane?
Okay, so we already know that the rate of change for S is 400, and because it's decreasing, it's a negative rate of change.
Wait.
In respect.
Tell us about the problem. There's a plane, and then.
Yeah,
But she was doing so
Okay.
fast.
Well, there's a plane moving, and we know that when S is 10, so when the distance between here and the radar is 10.
The radar. Okay, there's the radar.
The rate of change is 400, and because it's a direction, because it's decreasing the distance, it's negative 400. So the rate is negative, and with respect to t, ds over dt was negative 400. Okay. And it's at when s equals 10 because that's the distance to it. And if you want to find x, we can use the Pythagorean theorem.
Mm-hmm.
So we know that x squared plus we're given that as 6, so x squared plus 6 squared equals as.
It's a constant.
So, yeah, so first we do the Pythagorean theorem, and we get that x equals 10, the square root of 10 squared minus 36, which is 8. And then.
Oh, you didn't remember the rest? I thought you said you were going to explain it because you got really excited about it.
So first we have our equation that we got from the beginning, from the Pythagorean theorem. X squared plus 6 squared equals s squared. And then we differentiate the equation that we had before with respect to t. And so we do power whatever 2x dx over dt equals 2s dx over dt. This goes away because. And then we solve for dx over dt. So we divide both sides by 2x. So the 2 goes away, and we end up with s over x. And then we substitute the s value that we had before, that we got in the beginning, s equals 10. And we end up with dx over dt. The rate of change for x is 10 over 8. Okay, 10 over 8. 10 over 8, not sure, guys. It's 10 over 8. 400, so it's just negative 500. And so the velocity is negative 500, but since we only want the speed, which doesn't have a direction, It just
Speed is the absolute value of velocity with respect to t, so that's why it's 500.
That's the speed of
Of the plane.
the plane at that instant. Do we have questions, guys?
No. No, good job.
Okay.
Equals 0 and slides away from the wall at a rate of 0.8 meters per second. Find the velocity of the top of the ladder at time t equals 1. So what we're given a ladder that's 5 meters. The bottom of the ladder is 0.5 meters from the wall at time t equals 0, and the ladder starts sliding away from the wall at 0.8 meters per second. We're finding the velocity of the top of the ladder when t time equals 1.
So what we do is we try to find dh over dt at t equals 1. And we are given that the dx over dt is 0.08 meters per second at x of 0, and then x of 0 equals 1.5 meters. So we use the Pythagorean theorem where we get x squared plus h squared equals 5 squared because we're already given the hypotenuse. And so then we find the derivative in respect to t. So 2x dx over dt plus 2h dh over dt equals 0. And then after solving everything and bringing dh over dt to the left, we get negative 0.8 x over h meters per second. And so therefore we substitute in the values for x and h of 1, and we get negative 0.8 times 2 over 5, 2 over 3 over 4.44, and therefore we get the answer negative 0.41 meters per second. And so the velocity of the ladder at t equals 1 is negative 0.41 meters per second.
Why is it negative though? Why is it negative?
Because it's negative because that's how much it's sliding away from the ladder. Because that's the velocity
Why is it negative, not positive?
Because the top is going down.
Increasing.
Yeah.
Okay, thank you.
The angle of elevation of the camera shown in this figure at 10 seconds after the liftoff.
What is given is dc over dt equals velocity of rocket. We have to find d0 over dt when at t equals 10 and s at 5,000.
The equation for the solution is tan 0 equals s over 2,000. First, you have to find the secant. Well, no, you have to put secant to 0, and d0 over dt equals 1 over 2,000 ds over dt. And d0 over dt equals cosine. Wait.
It's not 0, it's theta. It's the angle. Yeah. Yeah, not 0 because they might think it's a 0.
Because they look like.
Yeah, it looks like 0, but it's
What's it
theta.
called,
Theta. Theta.
Theta.
T-H-E-T-A. It's a Greek letter. It's a Greek letter.
when you don't know the angles of the
Yeah. Okay. Back here.
So cosine would equal theta 100t over 2,000, and which it would equal 2,000 over the square root of s squared plus 200. So we square it, and we have 100t over 2,000.
The answer would be when t equals 10 and s equals 5,000, divided by 110 over 5,000 squared plus 2,000 squared equals 2 over 29 radian per second.
So what is that 2 over 29 radian per second? What is that? Go back to the question.
Well, that's the rate of change of the angle.
Okay, rate of change of the angle. So you need to write that down, please.
Okay.
Use the marker. Rate of change of the angle. If you have observed, this problem actually is similar to another problem that was presented. Which
The balloon.
the balloon, right? Okay, thank you.
angle between the telescope and the ground is equals to pi over 3. And it's changing to the rate of 0.9 radians per minute. The question is, what is the rocket's velocity at that moment?
Smile.
Can you repeat the question?
It's in the book. All right.
They don't have.
Well,
Let's get it recorded.
Come on, let's continue.
You suck!
So what we were giving was that theta is equal to pi over 3. And the derivative of theta over the derivative of time is 0.9 radians per minute. So radiant. So they give us this equation too. It's tangent theta equals y over 6. And so we do the derivative of that, which was secant squared theta d theta over dt equals 1 over 6 dy over dt.
Okay.
And then we just did we just solved it. And the answer is 21.6 kilometers.
How do you solve it? What did you use?
Oh my god, Miss, are we done?
Miss, do we have the same?
Who cares? You finish it.
What's made up?
Theta
It's the angle.
is 0 with the
It's the rate of change angle.
Okay, go by.
Wait.
I did explain, and we have a book from him. You can put it up. You thought I forget you?
At a rate of 4.5 cubic feet per minute. We need to find the rate of change of the radius when the radius is 2 feet. We're given this dv over dt, which is 9 over 2, and we gotta find the dr over dt, which is the rate of change, the radius at 2 feet. So we're gonna use the equation of the volume of the balloon. This is the equation we gotta use. Also, the solution is that dv over dt is equal to 4 over 3 pi r cube, which is this equation, and then we gotta.
I think you left out something there. A dr over dt.
Yeah, we try it.
Oh, okay.
So now we gotta find the derivative of this, and which is dv over dt equals to 12 over 3 pi r squared dr over dt. Then we gotta solve for dr over dt, so we divide this.
So 3 is 4, so like the 4 is coming from the 12 divided by 3. So the answer was 0.09, but we have to find the dr over dt. So we substitute that dv over dt, that is 9 over 2, and the r, the radius is 2. We put it over there and we get the dr over dt, that is 0.09.
Approximately 0.09.
Okay, so what is that? Write the answer in
That's the-
statement 4.
So the rate of change of the radius is 0.09 foot per minute.
Yeah, write it down here, please, on the paper. Can you write it down? This is something different from the other problems presented, right? Because you have a spherical balloon being inflated, so the volume of the balloon is the one that's changing, and you want to find the rate of change of the radius. The diagrams are awesome. You see that?
Yeah.
You see the drawing there?
Yeah.
So do we have questions? No. So we have one more group, Ahmad's group, and we will be done. Okay, we're ready.
So the problem, Farmer John's tractor traveling at 3 miles per second pulls a rope attached to a bale of hay through a pulley. With dimensions as indicated in figure 7, this is figure 7, how fast is the bale rising when the tractor is 5 meters from the bale? And this is not John scale because it's Turbo John.
Great. So this is X, this is the bale of hay, and these are the dimensions they gave us. This is the length of bale of hay, well actually not the length of bale of hay. How far the bale of hay is suspended from the ground is H. It can go up to 6. So anyway, just keep that in mind. Okay, we're trying to find dH over dt, which is derivative of h with respect to t.
What's the H?
H is
The height.
the height from which the bale is suspended from the ground. Okay, and when x is 5, that means when here it says here, yeah, anyway, from when the tractor is 5 meters away from the bale of hay, as you can see in the graph. Okay, and they gave us that dx over dt is 3 meters per second, which is basically derivative of x with respect to time. Yeah. Like, the total length of the road, you can get it with Pythagorean theorem. I can't say it in English.
Pythagorean theorem.
I can't say it in English.
Okay, don't worry about it. We know what it is. Everybody knows Pythagorean theorem?
No.
No.
Okay.
Basically, we're trying to find the length of this right now. Wait, no. Are we really doing this right now? That's fine. We'll just continue whatever. Okay. So L is this, and this part over here is this. 6 minus h, which is this.
I can't see.
It's not my problem. Okay. We know that dl over dt equals 0 because the derivative of something constant of a constant is 0.
Is 0.
So we keep that in mind.
Where's the L though in the diagram?
No, we didn't draw. We said L right now. We just said it as we're speaking. L is this. It's the total length of the road.
Yeah, the total length of the y plus the 6 minus h.
Yeah.
Yeah. Okay.
Y is this part. Square root of x squared plus 4.5. Right. Swag. dl over dt equals. Anyway, good. Yeah. Okay. So we're fine. So we know that dl over dt equals 0, and it's just a Pythagorean theorem. But the derivatives of those, of the two smaller ones, the two smaller sides, equal minus minus the what's it called? The derivative of the short one equals 0. So basically, you get this equation, which equals dl over dt equals x dx over dt square root I don't know. See, it doesn't matter. Anyway, you plug in the values, you get the answer, and that's it. And the answer is the bale is rising at 2.23 meters per second when the tractor is 5 meters away from the bale.
That's a question.
Okay.
Huh? Gangster writing.
What's gangster writing?
Yeah, they call that gangster writing.
They don't know if it's gangster.
I don't know.
Okay, we're done.
Okay, so they're done. Thank you. This is the road, right? You should have Muhammad. Ahmad. This is your rope, right? Because it's composed of 2 parts. The rope is composed of 2 parts. This part here
I couldn't see what he was
Which
saying.
they got by Pythagorean theorem at this part here.
No, why was just this part? Why was
I know, y is just this part.
Hey, can you explain it?
Yeah. And then this is the 6 minus 8.
Yeah.
Yeah. And this is your h right here. This is your h.
I know one thing that was like watching that.
Whatever.